So today we're going to do special products. These are three special multiplicative properties of polynomials. We are going to learn them today, and then later on, tomorrow or maybe the next day, we're going to learn how to factor and go backwards. Yep. From yesterday? Well, I'm going to post the video, so.
Yesterday?
Well, you know, Monday. Okay, so this one is sum of square of a sum. This one is difference. I'm sorry. Square of a difference. And this one is sum and difference. This is multiplication or product of a sum and a difference. Call this product of. Okay, so these are three shortcuts that you're going to have memorized. Seat. Thank you. You're going to have to memorize all three of these. They look confusing right now, but once we use them a couple times, you'll see they're all very similar. So really, if you have one memorized, the other ones kind of just roll off of one. We're going to start with sum of squares, or square of sum. I'm going to show you why these things are the way they are first, and then we're going to do some problems and demonstrate how to use them. So, square of sum, why does this work? Alright, so a plus b squared means a plus b times a plus b. Now, we learned the FOIL method recently, so let's FOIL this out and see what we get. A times a is a squared. A times b is ab. Am I moving too fast?
No.
B times a is
AB.
ab or ba, but it's a like term with this one, right? And then b times b is. So do you see how this becomes a squared plus 2ab plus b squared? Do you see where this 2 comes from?
Yeah.
Yes. Okay, so if we have a square of sums, plural, sums, if we FOIL it out, you see that it gets us this. Now, the whole point of doing this process is that we don't have to FOIL it out. These are essentially shortcuts. Okay, so this is why this equals this. Do you all understand where this comes from now?
Yes.
Yes. Okay, so let's look at why the other one works, square of differences. And it's essentially the exact same thing with one small difference. What's the difference?
The
You have to
subtraction.
distribute this minus, right?
Yeah. So what's the difference between this and this?
One
This
is
one's
negative.
minus 2, right? This one's plus 2?
Yeah.
All right, so, well, if this is minus 2, shouldn't this also be minus 2? No. You'll see why. So a times a is a squared. Negative b times a is negative ba, or negative ab. Then negative b times a is, wait, I already did that, I'm sorry. Negative b times b is, wait, I'm confusing myself. A times a is a squared. A times negative b is negative ba. Negative b times a is negative ba. And negative b times negative b is positive b squared. So when we add this together, we get a squared minus 2 BA or AB, doesn't matter which way we have it, plus B squared. So do you see where this comes from?
Yes.
Okay. All right. Now this one was like number 20 on your homework last week. You guys remember when that middle term canceled out and we were left with the binomial? And I said, keep an eye on this. Remember, this will come back and we'll see another one like this. This is that case. Why does that middle term cancel out?
Because you get addition and subtraction and get to the table.
Yeah, those two middle terms are going to have different signs, right? And instead of stacking like we saw here, they're just going to cancel. All right, so I'll show you this one. A plus B times A minus B. I'll do it quickly. A squared negative AB positive AB negative B squared. Two middle terms cancel. And you're left with A squared minus B squared. Okay, so these are the special products you need to have memorized. This is why it works for all three. Can I erase this?
Yeah.
One more second? Sure. This is why it works for all three. And now we're going to use these special products to essentially skip over the FOIL method. And this only works because this is times itself. Now, if this was A plus B times C plus D, we would have to use the FOIL method. There's no other way to do it, okay? But since this is times itself, we can use this special property and get to this. Now, it doesn't make sense yet until you see it done with other binomials. And I'll show you what I mean. So let's look at example 1a, which is 7x plus 2 squared. Okay, so I'm going to baby step you through the first one, and then we're going to kind of start skipping some steps as we move along. So 7x plus 2 squared means seven x plus 2 times itself, right? Okay, so underneath of this, I'm going to write this rule, or this special product. Okay, just so we can follow along with the format. So we know that a squared a plus b squared equals what? A squared plus 2ab plus b squared. Again, we're going to have this memorized. Okay. Now, looking at this and looking at this, what is A? 7 or 7x? 7x. What is B? 2. Good. Okay, so we're basically going to say we know what A and B are, plug it into here. So what is A? It's 7x squared plus 2 times A, which is 7x, times B, which is 2. Sorry, I'm running out of room. Plus B squared, which is 2 squared. Can you guys see this? Yes? Okay, so I know A is 7x and I know B is 2 because it follows that form, right?
Yeah.
So I'm going to plug in 7x for A squared, which is 7x squared. The 2 stays a 2. A becomes 7x, B becomes 2, B becomes 2, and the square stays a square, and this square stays a square. All right, so now we're going to simplify. This is going to come down here. We're going to simplify. 7x squared is what? 49x squared. 2 times 7x times 2 is 14x times 2 is 28x. And 2 squared is 4. We're done. That's it. Okay. I know this looks confusing the first time I do it. So that's why I'm going to do another one. Before I do the other one, let's FOIL this out and just make sure that that matches with our FOIL. So if we had 7x plus 2 squared, it's the same thing as 7x plus 2 times 7x plus 2, right?
Yeah.
Let's FOIL it out. 7x times 7x is
49.
49x squared. 7x times 2 is 2 times 7x is 2 times 2 is 4. 49x squared plus 28x plus 4. Same thing, right? So this is a shortcut, even though this does not look like a shortcut. Because like I said, I'm baby stepping you through this. We're not going to do all this for every problem. I just wanted to show it as clearly as I could the first time. All right. Pretty soon, we're going to be going from here to here very quickly. All right. Let's do one more. I'll write it a little bit small. Can I erase this here?
Yeah.
You guys have it written down, and if you don't, it's in your textbook on page 486. All right, let's do example 1b. 8c plus 3d squared. Okay, is this square of sums or square of differences? Square of sums, because we see the plus. All right, good. So that means we're going to use this form, which we have memorized. Not yet, but you will. A plus b squared equals a squared plus 2ab plus b squared. And we are going to substitute what we know in for this. What is a?
8c.
So that's 8c squared. Why am I putting the 8 and the c in parentheses? Why not just put 8c squared?
It's one.
Because not in parentheses, only the C will be squared.
Correct. Good. So we got to square the 8 and the c. Very good. All right. 2 stays at 2. A is 8c. B is 3d. And plus 3d squared. Okay. Which equals 8c squared is
64.
c squared. 2 times 8c is 16c. Times 3d is, let's do it like this. What's 2 times 3?
2.
Times 8.
48.
And cd. And then 3d squared is 9
90.
d squared. Great. So we went from here, input our values into here, and we came out here. So tomorrow, or possibly the next day, depending on how far we get with this, we're going to do something called factoring polynomials. And we're going to need to be able to go from here back to here. There's a process, and it won't make any sense unless we see how it works from here to here. All right? Questions on example 1, part B? No questions.